Okay, so we will start again from here. So if you look at it, how many basically equilibrium equations we have over here? If you look at it, there will be a combination of on this single frame we will have how many equilibrium equations? You already know. You will, for one frame you will have three equilibrium equations. You will have three equilibrium equations here, and you will have three equilibrium equations here. Okay, so if you look at it, there will be a total of how many equilibrium equations on both the parts of the frame? 6 equilibrium equations. And how many unknowns do you have? If you look at it, 1, 2, okay, these will be unknowns. Then again 3, 4, 5 and 6. So you have basically 6 equilibrium equations, and if you look at it, you will have 6 unknowns. You also have 6 unknowns: 1, 2, 3, 4, 5, 6. You remember bx by and bx by are the same, so you can say 1, 2, 3, 4, 5, 6. So 6 unknowns and 6 equilibrium equations. And if you come here, what does this tell you over here is that for these cases the number of unknowns will be equals to number of equilibrium equations only. So this is very important. Once this has been decided, the other thing is that you first have to say the calculate the friction. Number one step is calculate the frictional forces using the equilibrium equations only. Okay, so you can basically calculate this. He is trying to tell you this frictional force Fa, this frictional force Fa and Fc will be calculated by means of these three equilibrium equations. So you will have a value of Fa, you will have a value of Na, and you will have the value of Fc, Nc, Bx, By. They will all be calculated using these equilibrium equations, because remember you have three equilibrium equations here and you have three equilibrium equations here, total 6. So you will be calculating all these unknowns by the virtue of these equilibrium equations. Once this is being done, okay, you will have calculated Na and Fa. You will check whether your body remains in equilibrium or it doesn't remains. How will you check? You will apply the check here. Okay, remember the body has to stay below this point. The maximum where Fs is basically going to be maximum, which is what is the value? It will be mu s into n. Fs equals to mu s into n. So what you will do, you will check here, and you will say that this value of Fa, for example, if calculated, comes out to be, you say Fa, for example, comes out to be 26 Newton. This is 26 Newton. This is what? Fa. This comes out to be. Now, when you multiply the value of 0.3 into Na, the normal Na means normal direction at A, this value must be basically greater than, must always be greater than the value of Fa, which is 26 Newton. And you will apply the same check over here. The result must come as the value of Fc, the value of Fc which you have calculated from equilibrium equations. It must be less than or equal to the value of 0.05 Nc. Okay, because this 0.5 Nc and this 0.3 Na corresponds to which point? It is corresponding to this point. Okay, it is corresponding to the maximum point, and the body, since for this case one problems, the body has to be below this point. It has to be below this point to satisfy that the body is in static equilibrium. So this is how you will check for your case 1 problems. Okay, so we now proceed to the other basically problems of case 2, how to deal with the case 2. If you look, this is our case 2 problems. This is our case 2 problems. So this tells you that the impending motion is acting at all points. Okay, so if you look at it from in the case 1, remember in the case 1 we were always below. In the case 1 we were always below this point. This case tells you that the impending motion is occurring at all points. So now you will always be specifically at this point. You will always be at this point. You will always be at this point, because he is saying that impending motion is occurring at all points. So these problems can be identified by the fact that impending motion of the slipping of the body, impending motion and the slipping of the body at all points of contact can take place at the same time. Okay. So in the previous, if you look at it, here you were not allowed, they say, you see, you were not allowed to use this equation directly, either at this point or at this point. You have to calculate these values through the equilibrium equations and then check it with this 0.3 nm and 0.5 nc, but you are not allowed, and it is in red. But here he gives you the license to use F equals to mu Sn, here he says you can use the license given, F equals to mu s into n, at all points of contact. You have to use it at all points of contact. You are given the license, and what are those points? If you look at it, what are those points? This point is certainly this point of contact and this point of contact. Okay. And what does it means that for this type of a body, which is given to us? So now if you look at it, if you draw the FBD of this diagram, it can basically slip in this direction. So the frictional component comes in this direction. The frictional component is coming in this direction. Okay, this is the direction FA. This body can basically slip. When it is slipping, it will go in this direction. It will go in this direction. Remember, it go downwards. So the frictional component will basically be coming in which direction? To stop it from going downwards, this is the frictional direction. And you can definitely very easily say that the normal reaction of the ground at point A will be this, and that this is normal reaction of the wall on the frame will be this. Okay, so this is how you draw the FBD. This is how you draw the FBD. Okay. On these, in these problems. Okay, this is again very important that here, just to let you know, here you are basically being allowed to use the friction equation. They have given you that you can use the frictional equations on these types of problems. Okay. So basically, how will basically you and they are giving you to use F equals to mu Sn at which point? At this point. At this point. Okay, at this point, and this is the point. Remember, this is the point where your Fs will be equals to F max, maximum point, equals to mu s into n. Remember, this is because this is the maximum point on this F. After you just move slightly, this FSL will not hold and it will become FK, because this is the motion area. This is the no motion area. So now look, he says that in these equations, the number of equilibrium equations plus the frictional equations will be equals to the number of unknowns. So if you look at it, what are going to be the number of unknowns here? Fa is an unknown, Na is an unknown, and Fb is an unknown, and Nb is an unknown. These are the four unknowns, and theta is an unknown. So how many unknowns are there? There are basically 5 unknowns. And what will be the equilibrium equations given to us for this kind of a system? The equilibrium equations that we have basically number of equilibrium equations plus the frictional equations. So how many equilibrium equations that you can basically have over here? Okay, so you basically have to have, if you look at it, you will have 3 equilibrium equations. You will have the 3 equilibrium equations acting over here. Okay, 3 equilibrium equations acting over here. And basically what will be the number of equilibrium equations that they have defined as 3. Okay, and how many frictional equations that you basically going to solve, and to get it completely done, this you will say you will have the frictional equation. This is 1, and there is another frictional equation 2. So you will have 3 equilibrium equations, okay, and you will have 2 frictional equations. Okay, you have 2 frictional equations. So you can say what to, and number of unknowns you can already have calculated. Your unknowns will be 1, 2, 3, 4 and 5. Equilibrium equations will be how many? 1, 2, 3 equilibrium equations, and you will have 2 frictional equations. 2 frictional equations, one can be applied over here, the other frictional equation can be applied over here. Okay, so 2 frictional equations at this point and this point, and basically 3 plus 2 is 5. So 5 unknowns, and you have you can write it as 3 equilibrium equations plus 2 frictional equations. So 3 plus 2 is 5, and what number of unknowns that was over here is also 5. So if a scenario happens like this, okay, it is a perfect case for the case 2 type of a problem. Okay, so once this is being done, you can apply the equations of equilibrium over here. What is the equation of equilibrium? Fx, Fy and F. These are the 3 equations of equilibrium. Okay, these are the 3 equations of the equilibrium. And what about the frictional equation? You will see, because if you look in this problem, they have already explained you in you see, it can be identified by the fact that impending motion or slipping of the body at all point of contact can take place. So you can apply F equals to mu Sn at all point of contacts. Okay, so you can apply once the equilibrium equations. Now at this point A, you can apply directly F is equals to 0.3 times of Na. Okay, so if you apply, you have already calculated Fa and you already know Na, so you can get your value of Fa from here. Okay, it can be equal, and Fb again you have got calculated Nb, so 0.4 times of Nb will give you the value of Fb. Okay, so this is how basically in the numerical, when become we'll be able to understand even more practically. So these types of problems are basically common domain of impending motion at all points. So motion is there, so that is why we're using this equation, Fa equals to 0.3 Na and Fb equals to 0.4 times of Nb. Okay, so we shall stop here and we'll come with another case.